Hello, in this video we're discussing angles, and a lot of these you will have seen before, but I'm going to say it again. It's important to pay attention to the details because we'll be working more with more complex figures and things. So pay attention to how we name angles and the exact definitions. So of course, when we say an angle, it consists of two different rays. So you see these red rays coming from point B, and they have to have the same initial point. So it's considered an angle because they have the same initial point B, two different rays with the same endpoint. And then we call B the vertex of an angle. And then BC and BA are what we call the sides of an angle. And then we have the interior of the angle, that's all of the space inside of that angle, and then the exterior is, of course, what's outside of the angle. Now, when we name an angle, we can name it with 3 letters or with 1 letter, depending on the diagram. So in this particular one, I could just call this angle B and name it by the vertex. However, sometimes diagrams, if I just said angle B, it would be vague. So for example, if I had, in this diagram, if I had another ray coming off of here, ray BD, and I just said angle B, then it would be confusing of which angle B I was talking about. Would it be the very large angle, the top smaller one, or the bottom smaller one? So that's why we have to use 3 letters most of the time. When we use 3 letters, the vertex has to be the middle letter. So for example, if I was talking about that original one, that would be angle ABC. Now I could also name that CBA, and that would be the same angle. So I could also, when I have this more complex diagram, I might be talking about angle CBD, and that would specify to you that I'm talking about this very small bottom angle. Or I could be talking about the very large angle ABD. And that's the very large angle B. So be careful when you're naming angles. Make sure you're explicit when you need to be. And then reminder what an acute angle is. That just means it's an angle whose measure is between 0 degrees and 90 degrees. A right angle is one that measures 90 degrees. And then an obtuse angle is between 90 and 180. When we talk about congruent angles, we are talking about angles that have the same measure. So later in class, I'll go back to about congruence, but if I have the measure of angle A equals the measure of angle B, then I know that I can say angle A is congruent to angle B. Do you notice how I don't have the little m in front of the angle A and angle B anymore? Because I'm talking about congruence. I'm not talking about the measure of it anymore. I'm talking about that object angle A is congruent to object angle B. Now I have right angle starred because that is one of our proof cards that I want to make a specific definition for. So for your right angle card, let's write that in if-then form. So if an angle is right, then its measure is 90 degrees. You might also want to say an alternative would be if angle A is right, then the measure of angle A equals 90. And since this is a definition, we're going to write it the opposite way. It goes both ways. So I could also say if the measure of angle A, angle A, not 2 angles, the measure of angle A equals 90, then angle A is a right angle. Okay, so both ways, write that on your card. Sometimes if it helps you, you can draw a diagram. Okay. So do what you need to do on top of that, but I definitely need you to put the if-then statements in on your card. Moving on, so we also have what we call a straight angle, and that is simply an angle that measures exactly 180 degrees. Keep in mind that that means it looks like a straight line. Okay, so if I said this is angle A, then that measures 180 degrees. Adjacent angles, I don't know if you're familiar with that vocabulary. Adjacent angles have a common vertex and a side, but have no common interior endpoints. So it's kind of like that diagram that I drew in the very beginning with angles. Let's say we had angle B, and then this was angle A, this was C, and then this was D. So adjacent angles would be, they have a common vertex and a side. So BC would be the common side, and B would be the common endpoint. So our two angles would be angle ABC and angle DBC. Those would be considered adjacent angles. However, overlapping ones would not be considered adjacent. So I could not say angle ABC and angle ABD, the big one, because they share the same interior angle of ABC. So here's some naming practice. So if you want to pause the video and see if you can name the angles, then go ahead and do that. In this first one, if I name the angles, I could say JLK, I could say KLM, and then JLM. So I have the two, looks like right angles, and then the straight angle. And remember, there are different ways to name that too. If you said KLJ instead of JLK, that's totally okay. And then over here, we have three names. You could all ask for two, but these are all three ways you can name that one single angle. So make sure you're okay with that. If not, make sure to ask about it in class. So we have this protractor postulate, just like we had the ruler postulate for segments. The protractor postulate basically tells us that we are able to measure an angle, so take some floating angle in space and connect it to numbers that are on a protractor. Okay, so, and when we measure an angle in geometry, we are always talking about the absolute value. All right, so it's always a positive angle. Okay. When you get into trigonometry, that will change. But for geometry, we're talking about positive angles. All right, and then this angle addition postulate, this is also on your cards. So make sure you write this in if-then form. This one I think is good to have a diagram. So if P is in the interior of RST, and this is really just describing what this picture looks like. So you can say if, and then write the words, or you can draw this diagram. But notice that this diagram has P on the interior. So if that is true, then they're saying RSP, that's this angle right here, RSP, plus the angle PST, now I'm tracing that with green. That, if I add those two angles together, that will equal the larger angle RST. Okay, so another way of saying that is the two small angles equals the larger angle. And this is very similar to that segment addition postulate that we talked about in class with segments. So make sure you have that on your card. And let's use that So we're going to use this quite a bit in geometry, adding angles together. So for example, if I wanted to know what the measure of angle ABC was, I would just need to know these two smaller angles. So I have 50 degrees plus 80 degrees. That tells me that that big angle is 130 degrees. So the measure of angle ABC equals 130. All right, and then here we're using the same postulate, but we're kind of using it backwards. So we're solving for a different variable. So we're trying to find the measure of HLK. That's this angle right here, and that's a smaller angle. So the measure of angle HLK plus that 30-degree angle is going to equal that total angle, which is a right angle, or 90 degrees. So in order to solve for HLK, we're subtracting now. So just because it says angle addition doesn't mean that you're always going to be just adding whatever numbers are there, obviously. Make sure you are looking at the diagram. So that's how we know that HLK would be 60 degrees. Now let's talk about angle pair relationships, because a lot of times we will see angles as pairs, and there will be special kinds of diagrams that we need to pay attention to. So the first type are called vertical angles. And vertical angles consist of two angles whose sides form two pairs of opposite rays. So let's think about what opposite rays look like. And we talked about that in the last video. Opposite rays look like that. So they have the common endpoint, but go in opposite directions. And then here I have that. So the green and the blue sets of opposite rays, they have the same common endpoint. So it really just looks like an X, like two intersecting lines. So this angle right here and this angle right here would be considered vertical angles. Or in this same diagram, this angle right here and this angle right here would be considered vertical angles. Now, a linear pair consists of two adjacent angles whose non-common sides are opposite rays. So again, if I think about what that definition says, okay, opposite rays, I have two adjacent angles, and they're non-common sides. So they have a common side. There's their common side. So I have this angle right here, and then this angle right here. Those would be considered a linear pair because their non-common side makes our opposite rays, or basically a straight line. So two angles that add up to be a straight line. So now, how can we use this information? How is this helpful? So what do we know about a straight line? How many degrees is a straight line? Well, we know a straight angle is 180 degrees. So if they tell me in this diagram that angle 2 is 52 degrees, if you look at the linear pair with angle 2, that's angle 3 right here. So if I wanted to figure out, well, if I know that this whole line is 180 degrees, we're going to use that angle addition postulate. So angle 3, the measure of angle 3 plus 52 degrees, we know is 180. So if I subtract that, then I'm going to get that the measure of angle 3 is 128 degrees. Now, if I do that process again, but now I use a different straight angle, so if I use this straight angle right here in blue, then I would be adding the measure of angle 3, which is 128, plus the measure of angle 4. And I know that equals 180. So if I subtract 128, I'm going to get 52 degrees. And then if I keep doing that around the diagram, I know angle 1 will also be 128 degrees. So notice that angle 1 and angle 3, those are the vertical angles, those were both 128 degrees. And angle 4 and angle 2 were both 52 degrees. Okay, so that's one way we can use that in a geometric diagram. what you'll see more often is when we have variables. All right, so they want us to solve for x and y. So let's look at what we have here. We have this angle and this angle are a linear pair, so those should add up to be 180 degrees. So I'm going to just write an equation, 6x minus 6 plus 6x plus 6 equals 180. So that gives me 12x equals 180. So then that gives me, what is that, 15? So x equals 15. And then if I plug that back in, let's see, 15 means that that's going to be, let's see, 6 times 15. That would be 60 plus 30, so that'll be 90 degrees. Oh, that's nice. So this is a 90-degree angle. And then this is going to be, oh no, that's 90 minus 6. My bad. So 90 minus 6, that would be 84 degrees, and then this is going to be 90 plus 6, so that'll be 96 degrees. All right, so we can use that, and then we can set up another equation for the y. So I know this angle plus this angle will also add up to be 90 degrees. I'm sorry, 180. I think I just like saying 90. All right, so 9y plus 8y, 17y minus 7 equals 180. I'm going to have to scroll down here. I'm running out of room. So then I'm going to add that 7 over. That equals 187. Divide by the 17. And that's how we're going to get 11 for the y. So then if I plug in 11, that'll be 99 minus 3, which is 96. And then if I'll have 88 minus 4, so that'll be 84. All right, so that's how we know what those angle measures are and what x and y are. Notice again that the vertical angles end up being the same. So now let's talk about another kind of pair of angles, and that's complementary and supplementary angles. Complementary, and remember, this is not like the English word complimentary where you compliment someone on, oh, I like your hair, I like your dress, or something like that. That's not what I mean. Complementary angles mean that they are angles that add up to have a sum of 90 degrees. Okay, so they don't have to be adjacent angles, although a lot of times they are. So if I had a right angle and I had 2 of them, so this might be 30, this might be 60, those would be complementary angles. But they don't have to be attached like that. They could have a 30-degree angle right here and then a 60-degree angle separately somewhere else. And those would still be considered complementary. Supplementary means that 2 angles add up to be 180. So again, they could be like a linear pair. All right, so where they're adjacent, so this one might be, I don't know, let's say that's 20 degrees and that would be 160. Or again, they could be separate. So I could have a 20-degree angle floating here and then a 160 degree angle over here. Now, I do want us to write a specific definition for complementary and supplementary angles, and I'm going to do that at the bottom of this slide. Let's look at a few examples first, and then we'll go back to those proof cards. All right, so here, let's look at number 5 and 6. M is the complement of n, and the measure of angle M is 63. Find M. So here's another way they might use that word. They may not say complementary. They might say it's the complement of. All right, so that it still means that the measure of angle M plus the measure of angle N adds up to be 90 degrees. So if we know that one of them is 63 degrees, then all we have to do is subtract that 63 from the 90. So that means the measure of angle N is going to be 27 degrees. All right, same thing with supplementary. They might just use the word supplement. All right, so then we know that angle C plus the measure of angle D add up to equal 180. And then again, if you know what one of them measures is, then you can just subtract that measure from 180. So now we know that the measure of angle D is 71. So let's talk about our technical definitions for complementary angles. And again, I'm going to use specific angles instead of talking in general words. All right, so if angle A and angle B are complementary, then the measure of angle A plus the measure of angle B equals 90. And of course, since this is a definition, the opposite is true. If the measure of angle A plus the measure of angle B equals 90, then angle A and angle B are complementary. That's how definitions work, right? So our supplementary card is going to look very similar. So for supplementary angles, it's going to say if angle A and angle B are supplementary, then the measure of angle A plus the measure of angle B equals 180. Vice versa, if the measure of angle A plus the measure of angle B equals 180, then angle A and angle B are supplementary. Let's do a few more examples and then we'll be done with this lesson. So word problems will use these supplement and complements quite a bit, so we have to work on translating that. An angle has measure x. What is the measure of its supplement? So remember, when we talk about its supplement, that means x plus its supplement they add up to be 180. So if I wanted to know what x is or what its supplement is, then I would just subtract x. So anytime you see the words its supplement, then what you can fill in for that is 180 minus x. Same thing goes for the measure of its complement. So if I say its complement, then I can immediately replace it with 90 minus x. So, having said that, when I read a word problem, the supplement of an angle, so that means 180 minus x, because an angle is just x. Then it says is 4 times the measure of the angle. So is in math means equals. That means equals is 4 times the measure of the angle, 4 times x, 4x. So I just set up an equation, and now I can solve that for x. So then I can add the x over, and then divide by 5. 3. So I would know that the measure of the original angle is 36 degrees. All right, so then in this problem, an angle is, okay, so that, remember when you see angle, use x. Is means equal, so an angle is 20 less than, so we're going to take away 20 from its complement. So when I see its complement, then I know I'm doing 90 minus x. That's its complement, and there's 20 less than that, so I'm going to be subtracting off 20. So there's my equation. So we're trying to find the measure of that angle. So just combine your 90 minus 20, That would be 70. Add the x over to the other side, and then divide by the 2. So our original angle is 35 degrees.